We are talking about Meta Viewport, and here's MDN docs using Viewport Meta Tag to control layout on mobile browsers. Mobile browsers render pages in a virtual window. So I think probably we're answering our question from the previous video right here. How does it know it's in a mobile? Because mobile browsers have a virtual window. The viewport usually wider than the screen, so they don't need to squeeze every page layout into a tiny window, which would break many non-mobile optimized sites. So sites that aren't optimized for mobile. Users can pan and zoom to see different areas of the page. Mobile Safari introduced the Viewport Meta Tag to let web developers control viewport size and scale. Many other mobile browsers now support this tag, although it is not part of the web standard. Apple's documentation does a good job explaining how web developers can use this tag, but we had to do some detective work, figure out exactly how to implement it in Fennec, whatever. For example, Safari's documentation says the content is common to limited list, so blah, blah, blah. Tell two viewports at Quirks mode. Viewport basics. Meta name equal viewport content width, device width. Width property, we'll learn about that. A pixel is not a pixel. Viewport width and screen width. Common viewport sizes for mobile and tablet. So content initial scale, maximum scale. We'll come back and I actually want to read that with you. But first, I want to look at this right here. So the meta viewport, meta name viewport content equals width equals device width. Means take the device width and make that the width of the viewport. Make the viewport the width of the device width, because some mobile browsers make it wider so you could, pan and that. So take the width of the viewport and make it equal to the device width. That's what that does. And then meta viewport initial scale 1. You ready to get into the weeds on this? Initial scale 1. There are three kinds of pixels. There are physical pixels. Those are the pixels that are actually physically the physical pixels on my screen. There are device independent pixels. Let me show you what that is. Like right here, it's telling me, I don't have my sample page up anymore. Right here, it's telling me that Nexus 5X, let's go with iPhone 6 Plus. iPhone 6 Plus is 414 by 736. iPhone 6 Plus resolution is 1920 by 1080. 1920 by 1080, but here it's 414 by 736. Huh? What's 414 times 3? 414 times 3 times 4 times 5 times 2 times 3. I was looking for something easy there. 1920 by 1080. I didn't get it. $1920 by 1080. That's kind of odd. Let's try an iPhone 6 resolution. See what that is. iPhone 6 resolution. 6 Plus. iPhone 6 Plus. iPhone 5 resolution. iPhone 65. That's going to be a few years in the future. We probably won't be around. iPhone 5. 1136 by 640. iPhone 5. 1136 by 640. What's 2 times 320? 640. What's 2 times 568? 1136. So the resolution of this is 1136 by 640. Physical pixels, 1,136 physical pixels up and down by 640 physical pixels left and right. That's the physical pixels on that device. What does the user actually see? The device independent pixels, 320 by 568. So for every pixel you're looking at, the iPhone is using 2 physical pixels to show you that one device independent pixel. Right? So if it's rendering an image and the image is like 568 pixels wide, right? it is using 2 pixels for every pixel. So you got physical pixels, you have device-independent pixels, and then you also have CSS pixels. And so the physical pixels are the pixels that are physically built into a device. Device-independent pixels, some devices have a high pixel density, like that iPhone 5. This means they might be 1,000 pixels in width, but only show 500 pixels to the user. In such a device, for every device-independent pixel that they show to the user, there are 2 physical pixels making up that 1 pixel being shown to the user. And CSS pixels, as developers, the pixels we use to create our websites are known as CSS pixels. We map our CSS pixels to device-independent pixels with an initial scale equal to 1. This means that every one of our CSS pixels will take up 1 device-independent pixel. If we had an initial scale of 2, each one of our CSS pixels would take up 2 device-independent pixels. So we'd be zoomed in. So let's see that in action. So it's kind of like maybe more than you need to know. But we're down here. I'm just looking here to see if I have an example. Thought I had some cool examples in here. This is it. So this has no Meta Viewport. This does. And this page does have Meta Viewport. The width on this page matches the device-independent pixels. Right? So each of our CSS pixels match 1 device-independent pixel. This is a test to show how the Meta Viewport tag affects page. Each box on the page is 50 pixels wide. So each of these boxes here is 50 pixels wide. So here's no Meta Viewport. And that's 568 pixels, 320 pixels wide. And so each of these boxes was 50 pixels. We have 100, 200, 300, 400, 500, 600, 700, 800, 980. Mobile phones like to just take a page and say, hey, we're going to show it on 980. That's no Meta Viewport. Here we say Meta Viewport, meta name equals viewport, content equals width equals device width. So here you can see our viewport is equal to device width. Our device width is 320 pixels, and we have 100, 200, 320. Each of these are 50. And our initial scale is that our CSS pixels are matching each device-independent pixel. Okay? That's our initial scale. And so if I scale this up and say each of our CSS pixels will match 2 device-independent pixels, what's that going to look like? Are we going to zoom in? Or zoom out? We zoomed in because each of our CSS pixels is taking up 2 physical pixels, right? So we have 160, half of 320. So that's what width equals device width and initial scale equals 1 do. So meta, name equals viewport, and that's for mobile browsers, mobile phones. The content is equal to width equals device width, so the viewport's equal to the width of the device, which means that instead of this, where the viewport's equal to 980, the viewport is equal to the width of the device, and initial scale equals 1 means each of our CSS pixels map to 1 device-independent pixel, which might be different than physical pixels, because they have that high-resolution retina display, extra pixels for every pixel we're actually showing you, so it's just crisper. It's like old computers, right? Old computers, right, used to not have, let me see if I can get a big image. Come on, dog. What am I doing at this place? See, old computers, right?
Yeah.
I forget what my point was going to be, but you could actually see the pixels. That's what my point is going to be, that are making up the graphics on the screen. In this case, the graphics are letters. You could see the pixels. And so they just condense them smaller, 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 and it becomes a more precise image, clearer image. And so that's like a retina display. The physical pixels don't correspond to the device-independent pixels, right? And then we have our CSS pixels. So initial scale 1 means that for each CSS pixel, we're going to use 1 device-independent pixel. If it's 2, for each CSS pixel, we're using 2 device-independent pixels. And your device-independent pixels aren't necessarily the same as your physical pixels on the device. So you got that now? Cool. So we'll stop this video here, and then we will read the article in the next video.